Hi everybody. Today is the first of our flipped classes, and I'd like to cover a couple of quick topics today, and they're all found in chapters 1 and 2 of your book, which you might want to take a look at. And this is all about chemistry, the study of matter and the changes that matter undergoes. Today I'd like to cover the categories of science and branches of chemistry. And we'll be taking a look at that in the lab and also doing some classwork on this. You can also find this PowerPoint on the pickup folder at school. Well, the first thing we call it the categories of science. So general, big, overarching areas of the discipline, and they include pure science and applied science. And what's the difference between them? Well, pure science is sort of just what it says, pure science. Albert Einstein right here, he just loved science. And so a lot of people would probably say that Albert was a pure scientist. He just wanted knowledge for its own sake. So he didn't especially want to get rich or famous. He just loved science. He was doing pure science. So a person at a university, a professor, might be a pure scientist, just trying to learn new things. Now, if you want to apply something, apply your knowledge, you want to make something, you have a goal in mind, you want to solve a problem, you want to produce a product, you want to put it simply, you might want to think of it as trying to get rich, through science. You might say that, okay, you're an applied scientist. So a pure scientist, they just love, the beauty of what happens here. And an applied scientist says, all right, I'm going to make something really cool. I'm going to make a smartphone screen that's better than any other screen that's ever been made. What are the chemicals that I need for this? And once I make this, it's going to be, once I make this new screen, it's going to be used by Samsung and Apple and all these other companies, and I might end up getting rich. Perhaps I want to make a new kind of tire, one that gets better gas mileage or hugs the road better, or lasts longer. Perhaps I want to work with oil, and I want to separate the oil into different types of products, such as maybe WD-40 or car oil or gasoline, that kind of thing. And I want to do something. I have a goal in mind, and I want to apply my knowledge and make a product. So I might be an applied scientist then. So a pure scientist just loves science. An applied scientist might very well love science, but also wants to make something, wants to come up with a product. Okay, so next is the branches. So it's kind of difficult. The last thing that we talked about in the previous page was we call them the categories of science. Now we're going to the branches, and depending on what book you use, they might separate this into different categories, but our book uses 6 branches. The organic chemistry, inorganic chemistry, physical chemistry, analytical chemistry, biochemistry, theoretical chemistry, and nuclear. Actually, that's 7, isn't it? Silly me. So 7 different branches of chemistry. 7 of them, all right? So let's go back to these and talk about them quickly. Well, organic chemistry means that there's carbon atoms involved. Right here, there's a picture of a molecule that has carbon atoms, 1, 2, 3, 4, 5, 6 carbon atoms, and several hydrogen atoms, 1, 2, 3, 4, 5, 6 in this case. So the molecule, it has a whole bunch of carbon atoms. That means we're talking organic chemistry. It's a little bit different than, say, organic produce, organic apples, or organic meat, and that kind of thing. So examples of organic chemistry might be petrochemistry. So that refers to petroleum products, gasoline and things like that. Plastics. Plastics typically have quite a few carbon atoms in them. Cosmetics. So different kinds of, lipstick and things like that. Typically those are organic molecules as well. Well, the second one is called inorganic. And inorganic means not organic. So if you look at a molecule, it probably does not have any, or not, at least not very many, carbon atoms. Here's a quartz crystal, and quartz is made out of silicon and oxygen, but there's not very much carbon in it. So inorganic chemistry means not carbon. So as you can see here, many of them have some carbon. but typically not too much. So metallurgy, metals, not much carbon in that. Catalyst chemistry, catalysts make reactions work. Geologic chemistry, so you're talking about rocks and minerals and things like that. Not much carbon. The third branch of chemistry is called physical chemistry, or they call it P chemistry in college, in which we look at the properties and changes of matter and the relationship to energy. Almost always it involves energy. So every chemical reaction either takes in energy or gives off energy. That's called physical chemistry. So we're going to focus in on the term energy right here. For example, if there's explosives or fireworks or something like that, so there's energy given off. So probably as you study fireworks, you would be using physical chemistry skills to work on this. Next is analytical chemistry. So analytical means you're analyzing. So you have a sample and, oh, I want to analyze it. I want to figure out what's in there. How much of the stuff is in there? So analytical chemistry is defined as the composition and concentration of chemicals in a substance. So composition means what's something made up of? What's it made out of? So if you have a tire, what are the molecules in there that make up a tire? So that's the composition, and then how much of each thing is in there? That's the concentration of the chemicals. Or perhaps, if you suspect that your water supply there's something weird in there, something tastes funny, you might send in
Rosemary Desher to the office or call 2607.
You might send a water sample to a laboratory and ask them to figure out what is in the water, and they would send this back and say, well, you have 1,300 parts per million of, I don't know, lead in your water supply. So that's a concentration of chemicals. So analytical chemistry, you're analyzing the chemical, figuring out what it's made up of and how much of the stuff is there. The fifth category is biochemistry. So bio refers to biology, living chemistry. So the chemistry of living organisms. It's kind of like organic chemistry, but typically the molecules are bigger in biochemistry. They're big, look at this, big molecules, big protein molecules, big carbohydrates, big lipid molecules that you learned about in biology class. So you might use biochemistry skills if you study nutrition or proteins or different kind of drugs, or if you're looking at genetics. DNA, for example, is a big molecule, a biomolecule. So biochemistry, the chemistry of living things. Next is theoretical chemistry. Theoretical, it refers to the basic principles of chemistry, designing chemicals, like chemical engineering. So theoretical, what should happen? You're going to make something that's never been made before. So you might be involved in chemical engineering. So you think, well, gosh, if you look at the periodic table and you say, well, if carbon behaves like this, and right next to it is nitrogen, and that behaves in a particular way too, perhaps phosphorus is the element that I really need to add to this chemical to make it work just right. So I'm theorizing, and I think that phosphorus is what we need here, right? So theoretical chemistry, the basic principles of chemistry, designing chemicals, and designing chemicals. The last category is called nuclear chemistry. And nuclear chemistry refers to reactions of the nucleus. So you probably know that atoms are thought to have a nucleus, and inside of the nucleus there are protons and neutrons in there, and on the outside, way outside the nucleus, are electrons. And so nuclear chemistry refers to what happens in the nucleus of atoms. So we're done with our lesson for today, so let's go back very quickly one more time. Categories of science: pure science and applied. Pure, I love science so much. Applied science, ooh, I want to make something and get rich. Branches of chemistry, there's 7 of them. There's organic, deals with carbon. Inorganic, doesn't have to do with carbon. Physical chemistry, energy. Physical chemistry is energy. Analytical chemistry, oh, I'm going to analyze this. How much stuff is there? What's it made out of? Number 5, biochemistry. Bio is the giveaway. That it's referring to a living organism and the molecules that are found in living organisms. Theoretical chemistry, we're going to try and design something. I have a theory. I think that I can make something really cool based upon my knowledge of the periodic table and other chemicals. Nuclear chemistry refers to what happens in the nucleus, way in the middle of the atom, where there's protons and neutrons. So that's today's lesson on types of chemistry.